What problem does the proposed method, HalluciBot, aim to solve in the field of large language models, LLMs?
HalluciBot aims to solve the problem of hallucinations in large language models, LLMs. Specifically, it focuses on predicting the probability of hallucination before any generation of output for any type of query posed to an LLM. The method addresses the challenge of hallucinations, which occur when LLMs generate outputs that contradict the source content or provide unverifiable information. HalluciBot introduces a novel concept called truthful hallucination, where LLMs may memorize training data but struggle to answer similar queries that are worded differently. By training an encoder-based model using a multi-agent Monte Carlo simulation, HalluciBot can estimate the propensity of a query to hallucinate and the expected rate of hallucination through sampling. This method differs from traditional approaches that focus on post-generation analysis and provides a proactive solution to mitigate hallucination-related issues in LLMs.
How does the proposed method, HalluciBot, work, and what are the key steps involved in its methodology?
HalluciBot is a novel model designed to predict the probability of hallucination before generating outputs from large language models, LLMs. The key steps involved in the methodology of HalluciBot include 1. Query perturbation. HalluciBot uses a GPT-3.5 Turbo LLM agent to generate 5 perturbations of the original query, while maintaining the same semantic meaning. This process aims to induce diversity and disentangle the generation process from potential training bias. 2. Output generation. For each perturbation, the output generator deploys multiple GPT-3.5 Turbo LLM agents to generate outputs. This step ensures a comprehensive analysis by producing multiple outputs from the same query, addressing the complexity of LLMs with nucleus sampling decoding. 3. Monte Carlo simulation. HalluciBot employs a Monte Carlo simulation to derive empirical estimations of hallucination rates in LLMs. This method is used to map the probability of hallucination in the presence of random variables, considering the multiple confounding variables that contribute to hallucinations. 4. Training a classifier. After conducting the Monte Carlo simulation on a training corpus of queries spanning different datasets, HalluciBot trains an encoder-based classifier using BERT and Roberta models. The classifier is trained to estimate the probability density of hallucination based on the empirical estimates derived from the simulation. 5. Binary and multi-class labels. HalluciBot simplifies the problem by considering binary labels to assess the propensity of a query to hallucinate. It also utilizes multi-class labels to estimate the occurrence of hallucinations when queried and sampled under multiple trials. 6. Metrics for hallucination. The methodology includes evaluating accuracy and agreement metrics to assess the correctness of individual agents and the level of agreement among multiple agents in analyzing truthful hallucinations. 7. Empirical estimate. The probability of truthful hallucinations for a query is empirically estimated based on the output of the Monte Carlo simulation, using an indicator function to measure the incorrectness of generated outputs compared to the ground truth. 8. Scenario encoding. HalluciBot incorporates the query's scenario in the prompt to mitigate hallucinations and provide valuable signals related to the hallucination rate of the original query. 9. Reliability assessment. Cronbach's alpha is employed to assess the internal consistency of the Monte Carlo simulation at the corpus level, ensuring the reliability of the results. 10. Dataset coverage and scenario split. The experiment includes 13 datasets divided into extractive, multiple choice, and abstractive scenarios to evaluate the impact of context on hallucination rates in different query types.
What are the theoretical or practical benefits of using HalluciBot compared to existing methods for hallucination detection in LLMs?
The theoretical and practical benefits of using HalluciBot compared to existing methods for hallucination detection in large language models, LLMs, are significant. The key advantages include 1. Early detection of hallucination. HalluciBot predicts the probability of hallucination before any generation, providing a proactive approach to identifying potential hallucinations. This contrasts with existing methods that focus on post-generation analysis, allowing for preemptive measures to be taken. 2. Encoder-based model. HalluciBot is the first encoder-based model to derive an anticipated rate of hallucination for any type of query before generation. This approach enhances the accuracy and efficiency of hallucination detection, compared to methods that rely on multiple generations during a user's session. 3. Efficient training process. HalluciBot's training process involves perturbing queries and conducting a Monte Carlo simulation prior to user interaction, reducing computational waste during user sessions. This contrasts with prevalent methods that involve sampling during or after the user's session, leading to improved computational efficiency. 4. Generalizability. HalluciBot can generalize to systems with Retrieval Augmented Generation (RAG) context or few-shot question answering systems with an LLM generator, as well as systems accessible via API calls. This versatility allows for widespread implementation and applicability in various environments. 5. Accountability and quality assurance. By providing estimates of hallucination rates for different types of queries, HalluciBot imparts accountability to users regarding the quality of their queries. This can lead to improved user interactions with LLMs and enhance the overall reliability of generated outputs. 6. Statistical discoveries. HalluciBot's experiments yield behavioral and statistical insights, such as the probability of LLMs being exceptionally correct or completely incorrect in certain scenarios. These discoveries contribute to a deeper understanding of LLM behavior and can inform future research in the field of hallucination detection. 7. Scenario incorporation. HalluciBot incorporates the query scenario in its detection process, leading to improved accuracy and differentiation of similar queries with varying contexts. This feature enhances the model's ability to detect hallucinations accurately across different scenarios. In conclusion, HalluciBot offers a novel and effective approach to hallucination detection in LLMs, providing early detection, efficient training processes, generalizability, accountability, statistical insights, and scenario-specific detection capabilities. These benefits position HalluciBot as a valuable tool for improving the reliability and performance of LLMs in various applications.
How is the method validated or tested in the study of HalluciBot?
The method in the study of HalluciBot is validated through a rigorous evaluation process. Firstly, the study employs a Monte Carlo simulation to derive empirical estimations of hallucination rates in large language models, LLMs. This simulation is crucial as it accounts for the multiple confounding variables that contribute to hallucinations in LLMs. The probability density that a query induces hallucination is estimated through this simulation. Secondly, a classifier is trained based on the results of the Monte Carlo simulation, using a synthetic labeled set of queries and their corresponding rates of hallucinations. The classifier is trained to predict both binary labels, propensity to hallucinate, and multi-class labels, expected value of hallucinations if sampled multiple times. The validation accuracy for binary labels is reported as 73%, and for multi-class labels, it is also 73% for the top 3 labels. Additionally, metrics such as accuracy and agreement are used to assess the performance of the model. Accuracy measures the correctness of individual agents, while agreement evaluates the level of consensus among multiple agents. These metrics provide a comprehensive evaluation of the model's performance in predicting hallucinations before generation.
What specific results were achieved with HalluciBot in terms of validation accuracy and hallucination rate estimation?
HalluciBot achieved a validation accuracy of 73% on binary labels and 73% for the top 3 multi-class labels. In terms of hallucination rate estimation, HalluciBot was able to predict the expected rate of hallucination for any type of query before generation. The model was trained using a multi-agent Monte Carlo simulation, perturbing 369,837 queries multiple times to create unique variations while retaining the original semantic meaning. By sampling outputs from each query, including the original, and conducting a Monte Carlo simulation on 2,219,022 sampled outputs, HalluciBot derived an empirical estimate of the expected rate of hallucination for the original query. This approach allowed for the accurate estimation of the propensity of a query to hallucinate before any generation took place.
What are the limitations or drawbacks of HalluciBot as discussed in the paper?
The limitations or drawbacks of HalluciBot, as discussed in the paper, include the reliance on a Monte Carlo simulation to derive empirical estimations of hallucination rates in large language models, LLMs. This method may not provide a closed-form solution to model hallucinations due to the complexity of multiple confounding variables. Additionally, the paper mentions that HalluciBot's training procedure involves perturbing a large number of queries and conducting simulations on a significant amount of sampled outputs, which can be computationally intensive. Another limitation is the potential risk of overtraining LLMs and the opacity of their training data, which may introduce bias into the model. Furthermore, the paper notes that HalluciBot's performance varies across different question-answering scenarios, with abstractive QA showing significant dispersion of hallucination rates compared to other scenarios, indicating potential challenges in maintaining consistency in predictions. Additionally, the testing set poses challenges such as the absence of certain types of samples and a distribution of multi-class labels that diverges from the training and validation sets, which may impact the generalizability of HalluciBot's performance.